that could genuinely change everything. We're talking about a solid-state super battery. So let's analyze this thing together and see if the hype is actually real.
I mean, just think about it for a second. What if you could pull into a charging station, and by the time you've grabbed a coffee, your car is at 100%? That is the incredible promise here. But is it possible? Well, let's find out.
So this document right here, this is our key piece of evidence. It's a confidential performance test of something called the Donut Lab solid-state battery. We're going to treat this like a case file, dig into the data, and see what it really tells us.
Okay, but before we can even look at the results, we have to understand the experiment itself. How was this battery actually tested? Because as you'll see, the details are absolutely crucial.
First thing we got to get our heads around is this term, C rate. It's just a fancy way of talking about charging speed. So, a 1 C rate, that charges a battery in 1 hour. Simple enough. But the tests we're about to analyze go all the way up to 11 C. And to put that in perspective, if 1 C is your garden hose, 11 C is a full-blast fire hydrant. We are talking about a massive amount of power.
The second critical detail you need to know is the cooling setup. The engineers use these things called heat sinks. They're basically just designed to pull heat away from the battery. And they tested 2 different setups, one with maximum cooling using 2 heat sinks, and another one with less cooling using just 1. This little difference, as we're about to see, changes everything.
All right, let's dig into our first piece of evidence, the 5C test. Now remember, that's 5 times faster than a standard 1-hour charge. So how did the battery hold up?
Well, even with the less effective cooling setup, the battery went from 0 to a full 100% in just 735 seconds. That's a full charge in just a little over 12 minutes. Right off the bat, that is incredibly impressive.
Now, when you look at the raw data, something really interesting pops out. With less cooling, the charge was actually faster, 735 seconds compared to 813. Now, that probably means the higher temperature sped up the chemical reactions inside. But, as we're about to see, that speed, it comes at a cost.
And that cost was heat. The data shows that with the really robust cooling, the battery hit a totally manageable 47 degrees Celsius. But with less cooling, the temperature jumped to over 61 degrees. So yeah, it's getting hot. But at this stage, the test was still a clear success.
Look, a 12-minute charge is fantastic. But the engineers who ran this test, they didn't stop there. They wanted to find the absolute limit. And that brings us to the main event, the 11C test. This is where they basically hooked up that fire hydrant just to see what would happen.
And the result? It is absolutely staggering. A full 0 to 100% charge in just 438 seconds. That is 7 minutes and 18 seconds. This isn't just fast. This is truly game-changing speed.
Here's the data, straight from Table 7 in the report. You can see the time to get to 80% was under 5 minutes in both tests. The speed is undeniably real. But look closely at the data for that single heatsink test, because that's where the whole story takes a very sharp turn. Because all that incredible speed, well, it generated an incredible amount of heat. And in science, there are limits you just cannot cross.
And here, it is, the smoking gun, pulled straight from the report. During one of the attempts with just the single heatsink, they had to abort the test. Why? Because it hit the safety limit.
And just to put that into perspective, 90 degrees Celsius is 194 degrees Fahrenheit. That is dangerously hot. We are talking almost boiling water hot. You absolutely do not want that happening inside a battery pack.
This chart just shows how terrifyingly close they came. With proper cooling, the temperature was hot, but it was a manageable 63 degrees. But with less cooling, it skyrocketed to 89 degrees, just 1 single degree shy of the safety cutoff. This battery was pushed right to the very edge of failure. So, after going through all the evidence in this confidential report, what's our final conclusion? What have we really learned about this amazing and kind of scary piece of technology?
Okay, here's the bottom line. The promise of this battery? It is 100% real. This report confirms a full charge in under 8 minutes is actually possible, and without losing capacity. But the challenge is just as real. That incredible speed generates an extreme amount of heat, which is going to require a very powerful and probably very complex cooling system to keep it in check. And that really leaves us with the final question. This report proves the speed is achievable. That's a fact now. But the next great challenge isn't about charging faster anymore. It's about staying cool. Can engineers actually design a cooling system that can handle this kind of raw heat in a real car without making it too heavy
or too expensive, or too complicated? The answer to that question, well, that's what's going to determine the future.